Hello all, Amy Gurecki and Tiffany Jenkins here. We would like to talk to you about how cool and exciting parametric equations can really be. Just in case, I would like to give you a quick review on what I mean when talking about parametric equations. Parametric equations, by definition, are a pair of functions represented as x equals f of t and y equals g of t in the plane which describe the x and y coordinates of the graph of some curve in that plane. Doesn't that sound exciting? Well, today Tiffany and I would like to show you how you can construct your name by use of parametric equations. First, let's go over some examples that can help us work through and understand this process. We will be focusing our attention on keeping these parametric equations in the first quadrant and centered at point 33 for illustration purposes. In example number 1, we would like to construct a full circle that is tangent to the x and y axis and is centered at point 33. We know through calculus that x of t equals cosine of t and y of t equals sine of t gives us a circle with a radius equal to 1 unit length whose center is at the origin. However, we would like to have it center at point 33. This tells us that our radius will equal 3 and that x and y will have to shift away from the origin. We find the formula to equal x of t equals 3 cosine of t plus 3 and y of t equals 3 sine of t plus 3. By multiplying 3 gives us our radius of 3. Adding 3 to x gives us a shift to the right of 3 units. Adding 3 to y gives us a shift of 3 to upwards. As you can see, the circle is drawn as t goes from 0 to 2 pi. In example number 2, we would like to create a horizontal half circle. Our equation will look like x of t equals 3 cosine of t divided by 2 plus 3 and y of t equals 3 sine of t divided by 2 plus 3. As you can see, dividing the t by 2 gives us the half circle. In our third example, we would like to create a vertical half circle. We can do this by flipping the equations over and turning the positive sign to a negative as shown. In example number 4, we would like to create a quarter circle. To do this, we will divide t by 4. The equations x of t equals negative 3 sine of t divided by 4 plus 3 and y of t equals 3 cosine of t divided by 4 plus 3 will give us the picture shown below. In example number 5, we are creating another quarter circle that is flipped. We can see that sign is positive in this example. This shows us that by slightly altering an equation, we can derive a different picture. Now that you've been given the basics about parametric equations, we are going to write the name Tiffany using parametric equations. First, you want to begin by constructing a long segment off to the side. Construct another segment on top of the one we just created. Measure both segments. Make sure the longer one is of length 2 pi. Label the smaller segment t. The point that rests in between the two endpoints is the one we would like to animate. Go to Edit, Action Buttons, then Animate. Label this button right.
Let's begin with making the vertical line of the letter t. I would like to start at the point 1/2, 5. The first set of parametric equations, x sub 1 must equal 1/2 and y sub 1 must equal 5 when t equals 0. Therefore, you get the following equations as shown. To complete the next set of parametric equations when t equals 0, we get the following equations as shown. Remember that we are writing the name, not printing, so t was just the easy part. For I, we need to start with a quarter circle. The first set of parametric equations for I is x sub 3 and y sub 3. For the next set of parametric equations, I want a short straight line. I used x sub 4 and y sub 4. For the last part of I, we are making a smaller quarter circle, so we get the following parametric equations as shown. Now let's start on the f's. We want the value of x sub 6 to equal the value of x sub 5 when t equals 2 pi. This curve must be a narrow quarter circle, then we have x sub 6 and y sub 6. Next, we need a diagonal line that will connect to the part of the previous quarter circle, giving us a piece of the bottom part of the f. Starting at the point 3, negative 2, we get x sub 7 and y sub 7. Next, we need a quarter circle starting at 3, negative 2, once again, to get a piece of the loop part of the f. Therefore, we get x sub 8 and y sub 8. For the final piece of f, we take an eighth of a circle, and when t equals 2 pi, we want the x values to be equivalent as possible so that the curve lines up with the previous quarter circle, giving us x sub 9 and y sub 9. For the second f, you are going to use the same equations from the first f, except for the first set of parametric equations, and for the other sets, you need to have a shift to the right on the x-axis. For the first set of parametric equations, we want a quarter circle to connect the second f to the first f. I got x sub 10 and y sub 10. Here is what I did for the rest of the parametric equations. X sub 11, y sub 11, x sub 12, and y sub 12, and finally x sub 13 and y sub 13. Next, I used a semicircle to connect the f to the letter A. You want the y parametric equation to have the same value as the previous y parametric equation so that the curves connect nicely. I use the following set shown. For the next part of the A, I used semicircles to construct the top part of the A. I got x sub 15 and y sub 15. For the bottom part of the A, you want to have the same type of semicircle as we did for the top of A, just flipped over. Therefore, I got x sub 16 and y sub 16. I also stretched my equations to get my A. For the tail of the A, we will use a quarter circle, and we want the value of the x parametric equation to equal the same as the previous value of the x parametric equation, which will give us the following as shown. For the first part of n, we want to use a quarter circle when t equals 2 pi. The value of the parametric equation should equal the previous value of the x parametric equation. This gives us x sub 18 and y sub 18. When t equals 0 for the next curve, we get the following set of equations. For the next curve, we want a straight line giving us x sub 20 and y sub 20. For the next hump on the n, we want it to be the same as the previous hump, so we use the exact same equation from x sub 19 and y sub 19. Just add 1 to the x parametric equation, which will give you x sub 21 and y sub 21. For the last part of the n, the set of equations is similar to the first set of the parametric equation used for n, so we get x sub 22 and y sub 22. Y is constructed by 7 parametric equations as shown below, and consists of many quarter circles, a half circle, and a line. But we are not finished yet until we dot our I. When finished, click on the button labeled Write.
And there you have it. You should now know enough to be able to construct your own name by use of parametric equations. Have fun, and thanks for watching.